Okay, this video is being created in our Calculus 1 class to discuss the homework from section 2.6, homework 5. I'm going to go over problems 8 through 13. Cole sent me a message saying he was having some trouble understanding how to do these limits. So let's look at these limits together. When you do these, yours will be probably slightly different because of the randomization, but just give you an idea how to do these. So in this first limit, we're looking to find the limit as x approaches minus infinity of the quantity 1 minus x to the fourth over x squared plus 5x, all raised to the seventh power. So first of all, you need to think of this function here as a composition of functions. So it's like f of x is x to the seventh, this guy to the seventh, and g of x is what's inside. So we have f of g of x. But the bottom line is we had a theorem that if I have a continuous function for a composition of functions, like f itself is a continuous function, then I can bring the limit inside and just take the limit of the inside and then raise that to the seventh power. Okay? So because x to the seventh, f from f of g of x, the x to the seventh, the quantity to the seventh, this is a continuous function, I can bring this limit inside these parentheses and then take the limit of this inside function. Now the inside function is just a rational function, so it's a polynomial divided by a polynomial. When you take the limit of a polynomial as x goes to plus or minus infinity, in this case minus infinity, you want to take every term and divide it by the highest power of x that you see. So in other words, I want to take the numerator and multiply it by 1 over x to the fourth, and the denominator multiply it by 1 over x to the fourth. And then take the limit piece by piece. Okay, so as x goes to minus infinity, the limit of 1 divided by x to the fourth is 0, minus x to the fourth over x to the fourth is 1. So that stays 1. So we have minus 1 remaining in the numerator. And then in the denominator, I have x squared over x to the fourth. So in other words, 1 over x squared. As x goes to minus infinity, that goes to 0. And 5x over x to the fourth, as x goes to minus infinity, that's 5 over x cubed. That also goes to 0. So I have minus 1 over 0. Minus 1 over 0. In other words, this does not exist. Okay? So what happens here is that this guy goes to minus 1. This guy goes to 0. This guy goes to 0. So I have minus 1 over 0. That's essentially minus infinity to the seventh. This is still minus infinity. Okay, so we're going to put in minus infinity. Check our answer. And there we go. Okay, so it does not exist, but the thing is we can be more specific and say it goes to minus infinity. I hope that works for you. So let's go through and check on the other ones just to kind of make sure you're getting this. Okay, so in this case, we want to take the limit as x goes to infinity of this function f of x, this guy here. So this is not really a rational function because these are not polynomials once I have powers of x that are not integer powers, positive integer powers, but it's still treated as though it were a rational function. So I look for the highest power of x, since again I'm going to infinity, I look for the highest power of x. So let's see, highest power of x, 11 thirds is 3 and 2 thirds, 10 thirds is 3 and 1 third, so this is a little bigger. 17 fifths is 3 and 1 fifth, so 3 and 2 thirds is bigger. So the highest power of x I see here is 11 thirds, right? Square root of x is the same as x to the 1/2. So this is the highest power of x. So I have to multiply both the numerator and the denominator by 1 over x to the 11 thirds. And then take each piece and take the limit as x goes to infinity. So when I multiply the numerator and denominator by 1 over x to the 11 thirds, in the numerator I get 2, and then I get minus 1 over x to the 1/3, plus 8 over x to the 11 thirds. So as x goes to infinity, this guy is 2, this guy becomes minus 1 over x to the 1/3, so that goes to 0, plus 8 over x to the 1/3, again as x goes to infinity, so that goes to 0. And so in the numerator I'm left with 2. In the denominator, this one's a little tricky, but 17 fifths is smaller than 11 thirds, so I'm going to end up with 1 over x to a power, a small power. You can do the algebra and see what it is, but as x goes to infinity, that blows up, goes to infinity. So 1 over a huge, huge number, this goes to 0. 4 over this guy goes to 0. This guy goes to 0, okay? So basically I end up with 2, positive 2, and then all the rest of the terms are 0. So 2 divided by 0, that is going to positive infinity, right? As x approaches infinity, 2 divided by something that's going towards 0 is going to positive infinity. So this guy would be infinity. All right? Again, you should probably write these out. I'm trying to explain them to you, but slow me down, write them out, make sure you understand it, okay? All right, now I'm looking at a limit as x approaches a specific number, in this case, minus 7. X approaches minus 7. This superscript with a negative sign means approaching minus 7 from the left of minus 7. Or some people say the negative side of minus 7, but it's minus 7 from the left. That means numbers like, smaller than minus 7, like minus 7.1, minus 7.05, minus 7.01, getting closer and closer to minus 7, but from the left side of minus 7. So this number approaches 56, right? Minus 8 times minus 7 approaches 56. But then I have minus 7, but a little bit smaller than minus 7, like minus 7.01. So in other words, a little bit smaller than minus 7, plus 7, becomes a very tiny negative number, right? As x gets closer and closer to minus 7 from the left, this becomes very close to 0, but it's negative, very tiny negative number. So 56 divided by a tiny negative number, that gets closer and closer to negative infinity, right? Positive 56 divided by a tiny negative number gets closer and closer to negative infinity. So this limit will be negative infinity. So plug that in. There you go. Let's check our answer. So there, okay? So that's what we're looking at for that one. Let's keep going forward. Okay, so number 11. Here we want the limit as x approaches 1 of minus 1 over quantity x minus 1 squared. So this is a two-sided limit, right? It doesn't say which side of 1 I'm coming in on, so we have to think about it coming in from both sides. The nice thing about this one is the bottom will always be positive, no matter if 1 is coming in from the left of 1 or the right of 1. So I can just think of it as the two-sided limit. This guy will always stay positive, but it gets really close to 0, right? As x approaches 1, this gets really close to 0. So I have negative 1 over a tiny, tiny, small positive number close to 0. Again, negative number divided by a tiny, tiny, small positive number goes to minus infinity. So I'm going to go minus infinity. Okay, next question. Number 12. So now we have minus 2 over x squared minus 16. Okay, so the numerator always stays minus 2. And we want to think about it as x approaches 4 or minus 4, and then from either side, right? From the right side of 4, from the left side of 4, from the right side of minus 4, from the left side of minus 4. So as x approaches 4 from the right, just a little bit bigger than 4, right? 4.01, etc. This guy is close to 16, but a little bit bigger than 16. So the denominator itself is a little bit bigger than 0. So it's a tiny positive number. So minus 2 divided by a tiny positive number goes to minus infinity. So minus infinity. We'll check our answer. Good shape. Okay, now x is approaching 4 from the left side of 4, like 3.99, right? X is approaching 4 from the left side of 4, like around 3.99, or 3.999, getting closer and closer to 4. So this gets closer and closer to 16, but it's a little bit smaller than 16. So a number a little bit smaller than 16, minus 16, is going to be a negative number, right? Little bit negative number. So minus 2 over a tiny, tiny negative number. The negative signs cancel and it approaches positive infinity. So plug in positive infinity. We'll check our answer and we're good to go again. So we'll have the same process, same thought processes with minus 4. So I'm approaching minus 4 from the right side of minus 4. Now the right side of minus 4 is like around minus 3.99, right? Minus 3.999, something close to minus 4, but on the right of minus 4. So when I square that number, it becomes positive, and again, a little bit smaller than 16. So now again, I have a negative 2, negative number, divided by a small, tiny, negative number, right? A little bit smaller than 16 minus 16. So negative divided by tiny negative becomes positive infinity. Looking good, okay? All right, minus 4 from the left. Minus 4 from the left. Minus 4 from the left. We have minus 2 over, now minus 4 from the left, that's like minus 4.01, minus 4.001, etc. Okay? So that's a little bit bigger than 16, so when I take this, it's a tiny, tiny positive number. Minus 2 over a tiny positive number is going to minus infinity. So we'll plug in minus infinity, check our answer, and we're good to go. And I'll do one more since Cole asked for this, 8 through 13. All right, so find the limits of f of t as t approaches the given values. Here we have f of t is 6 minus 6 over t to the 1/5. We want t approaching 0 from the right, t approaching 0 from the left. Okay, so the limit is t approaches a number when there's no t in it. So this guy just stays 6, right? This will always just stay 6. So I just have to worry about this part. 6 over, now that's a tiny, tiny positive number. If I take the 5th root of a tiny, tiny positive number, it's still a tiny positive number. Okay, so a tiny positive number, 6 over a tiny positive number, this goes to positive infinity. So I have 6 minus positive infinity, then this whole thing goes to negative infinity. So we'll plug in negative infinity, check our answer, and we're good to go there. Now we want t approaching 0 from the left side of 0, so a really tiny negative number, right? Like negative 0.00001, something like that. So when I take the 5th root of that, I can take the 5th root of a negative number. You can take the odd roots of negative numbers, but it stays negative, right? So I have 6 over a tiny, tiny, tiny negative number, right? 6 over a tiny negative number. So 6 over a tiny negative number goes to negative infinity. So I have 6 minus a minus infinity, or 6 plus infinity. So that goes to infinity. Plug in infinity, check our answer, we're done. Hopefully that helps everybody with those questions where those were not indeterminate forms. Cole asked me thinking they were in indeterminate forms. Those were all, they could be determined. You just had to think carefully about whether you had a tiny positive or a tiny negative number most of the time. Hope that helps.